Welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom video with Coach Gu. And this is all about transformations, but specifically translations of functions. So on the first example, we can see we need to graph the parent function f of x equals the absolute value of x. Now remember, if we want to graph this, we just pick our points x, whatever we want. I always pick -2, -1, 0, 1, and 2, because I know that's going to be easy to work with. So then if I plug in -2 for x, it's going to be f of -2 equals absolute value of -2, which is just 2. So if I continue with this pattern, f of -1 would be 1, f of 0 would be 0, f of 1 would be 1, and f of 2 would be 2. So this is my parent function. Let's graph those points. -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. And let's connect it. Absolute value function needs to look like a V, okay? So boom, and on the other side, over here, there we go. So there's our parent function for absolute value. Okay, so now it wants us to graph f of x equals the absolute value of x minus 4. So I'm going to graph this one in red. So let's pick our points again. I'm going to go with -2, -1, 0, 1, and 2. And let's see what the output values will be. If I plug in -2 now, what would I get? Watch this. F of -2 equals this absolute value of -2 minus 4. What is the absolute value of -2? That is +2 minus 4. What is 2 minus 4? That's -2. So at -2, my y value is also going to be -2. Let's try for f of -1 now. F of -1. That's going to be the absolute value of -1 minus 4. The absolute value of -1 is just 1. And 1 minus 4 equals -3. So we can see it's -3. If we continue this trend, you're going to see that f of 0 is -4, f of 1 is -3, and f of 2 is -2. So let's plug these points in. Let's plot these points on our graph. -2, -2. -1, -3. 0, -4. 1, -3. And 2, -2. So we can see that our new graph right here, like this and like this. So a little lower under this graph on your notes, it asks what's the difference between the parent function and then the function f of x equals the absolute value of x minus 4. You might notice that the graph has shifted downwards. The graph shifted down 4 units. That's the difference. Now let's look at the second graph over here. Once again, graph the parent function. So I'm just going to go ahead and graph those points: -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. This is the parent function for absolute value, because we're always comparing our transformations to the parent function. And there we go. So this time we're graphing f of x equals the absolute value of x plus 1. So let's see what we get. X and y, -2, -1, 0, 1, and 2. If I plug in -2, what do I get? F of -2 equals the absolute value of -2 plus 1. What's the absolute value of -2? That's +2 plus 1. 2 plus 1 is 3. So at -2, I'll have 3. Let's try f of -1 just to see what it is. F of -1 equals the absolute value of -1 plus 1. Absolute value of -1 is 1, and then 1 plus 1 equals 2. And if we continue that, we'll see that we get 0 is going to be at 1, 1's going to be 2, and f of 2 is going to be 3. So let's plug these points in. -2, 3, -1, 2, 0, 1, 1, 2, and 2, 3. So then our graph now looks like this. So can you tell me the difference between the parent function and our new function, f of x equals absolute value of x plus 1? It shifted. Where did it shift? Up 1 unit. That's right. Nice. I hope you said that. There you go. So looking at these two graphs, we see that one shifted down 4 units and the other shifted up 1 unit. Now, looking at the equations, what gives you a hint as to how the graph moves? It's the number at the end right here. This -4 shifted down 4 units. This +1 shifted up 1 unit. So now let's take a look at some definitions. A change in the parent function. Remember, we're always comparing to the parent function. A change in the parent function is called a transformation. A shift in the graph is called a translation. Just like you shift from one language to another, we're shifting our graph from one spot to another. It's the exact same thing, trust me. When a number k, this is the mathematical definition now, when a number k is added to a function so that the form of the function looks like f of x equals absolute value of x plus k, it can be any function, but we just use absolute value. There is a vertical, that means up and down, translation in the graph of the parent function equal to k units up. So how many units up is equal to k? So let's take a look at an example then. With square root, we're going to graph the parent function of square root. So first of all, parent function, what values would I have? Let's find x. Remember, square root has to be non-negative, and easy numbers would be 0, 1, 4, and 9. If I plug in 0, what do I get? It would be f of 0 equals square root of 0. That equals 0, so 0, 0. F of 1 is going to be square root of 1, which is 1. So then f of 4 is going to be 2, and f of 9 is going to be 3. So let's plot these points. We got 0, 0. We got 1, 1. We got 4, 2. And we got 9, 3. So that's our original square root parent function. So now we're going to graph the vertical translation, f of x equals square root of x plus 3 in another color. So I'm going to use red. Now, we're going to do it first with mathematical way, and let's see how this one is. See how much effort we take on this one. We got x and y, same thing, 0, 1, 4, and 9. If I plug in 0, what do I get? I would be, look, like this, f of 0 equals the square root of 0 plus 3. Square root of 0 is 0. 0 plus 3 is 3, so y would be 3. Now let's do f of 1. F of 1 would be square root of 1 plus 3. What's the square root of 1? That's going to be 1. 1 plus 3. 1 plus 3 equals 4, so it'd be 4 over here. So then f of 4 would be 5, and f of 9 would be 6. So these are our new points. 0, 3, 1, 4, 4, 5, and 9, 6. And what can we say that this graph did compared to a parent function using our new vocabulary? It's translated up 3 units. Translated up 3 units. There we go. Now you can see that it might take a lot of time if you do each point with a mathematical equation over and over. So watch this. Another way we can utilize our knowledge of translations. Look at this last one. F of x equals square root of x minus 5 in another color. Looking at this equation, where do we think our graph will move? We would think that the graph translates 5 units down because of this minus 5 at the end. So what we can do is look at the parent function, that's the blue, and all the points we have, just count down 5 spaces. So we see this point right here. Let's move down 5. 1, 2, 3, 4, 5 spaces. Our new point's right here. And the next point right here. 1, 2, 3, 4, 5 spaces. My new point is right here. Same thing with the next point. 1, 2, 3, 4, 5 right here. 1, 2, 3, 4, 5 right here. And now we can just connect these points. Like we can see that's the exact same thing as the parent function, except it has been translated down 5 units. And so after graphing it, look, graphing was easy. We just counted spaces. Now we can just plug in the points into our table. What do we have? We've got right here is 0, negative 5. Right here we've got 1, negative 4. Over here, we've got 1, 2, 3, 4, negative 3. And lastly, over here, we've got 9, negative 2. And so you see this way is a lot less math to do. It's a lot quicker. That's how you can use your knowledge of translations to find the graph without doing so many equations over and over. On to the backside, go ahead and graph the parent function on both of these graphs for absolute value. And now let's perform the transformations that it asks for. We're going to graph f of x equals the absolute value of x minus 4. So let's see what values we have. This time, let's start with x, and you'll see why. We're going to start with x at 2, 3, 4, 5, and 6. If I plug in 2, f of 2 would be like this. F of 2 equals absolute value of 2 minus 4. What is 2 minus 4? That's negative 2. And the absolute value of negative 2 is just positive 2. So at 2, it's 2. Okay, what about f of 3 then? F of 3 would be the absolute value of 3 minus 4. What's 3 minus 4? That's negative 1. And the absolute value of negative 1 is positive 1. So f of 4 would be 0, f of 5 would be 1, and f of 6 would be 2. Just plug them in if you don't believe me. So let's plot these points. We got 2, 2, 3, 1, 4, 0, 5, 1, and 6, 2, which is somewhere over here. And let's connect these points. So now what is the difference between the parent function and f of x equals absolute value of x minus 4? It's translated 4 units right. You moved 4 units to the right. Alright, well let's look at the next one then. We're going to graph f of x equals the absolute value of x plus 1. So this time my x values, I'm going to choose negative 3, negative 2, negative 1, 0, and 1. Let's see what we get. When we plug in negative 3, f of negative 3 equals absolute value of negative 3 plus 1. What is negative 3 plus 1? That's negative 2. And the absolute value of negative 2 is positive 2. Okay, let's see what we get when we do f of negative 2. F of negative 2 equals the absolute value of negative 2 plus 1. Negative 2 plus 1 is negative 1. And the absolute value of negative 1 is just 1. And then if you work it out, f of negative 1 is going to be 0, f of 0 is going to be 1, and f of 1 is going to be 2. So let's plot these points. We got negative 3, positive 2, negative 2, positive 1, negative 1, 0, 0, 1, and 1, 2. What's the difference between the parent function and this graph, f of x equals absolute value of x plus 1? Translated 1 unit left. There we go. Let's take a look at these questions to check for understanding. What did f of x equals absolute value of x minus 4 close absolute value do to the parent function? That's the example right above. Remember that shifted or translated 4 units right. The next one, what did f of x equals absolute value of x minus 4 do to the parent function? That's the example on the front page. And you'll see that that one shifted, I'm just going to use quotes so I don't have to write shifted again, shifted 4 units down. So notice our equations are almost the exact same. We've got the x, we've got the negative 4, but somehow the translation was different between these two equations. So what do you think is the difference between the way the two functions are written that might account for the difference? That's where the negative 4 is. Where the negative 4 is. Is it on the inside or outside of the absolute value signs? When it was on the inside, when it was inside the function, we shifted 4 units right. When it was on the outside and we just tagged it in at the end, square root of x, absolute value of x minus 4, we shifted 4 units down. So the mathematical definition is when a number h is subtracted from a variable so that f of x equals absolute value of x minus h, could be anything, but we use absolute value, there is a horizontal translation in the graph of the parent function equal to h units to the right. Now be careful because this says subtracted. It's minus h, okay? So that means that if you see a plus sign in the equation, that's actually to the left. And when we see the minus sign, that's going to be to the right. We can look at this example up here. F of x equals absolute value of x minus 4. It's a minus sign. You think it goes left, but no, it goes to the right. On this one, f of x equals absolute value of x plus 1, a plus sign. You would think it moves to the right, but no, it's the opposite. It moves to the left. So make sure you know that. All right. So now let's do an example with a quadratic. Now the parent function for a quadratic is f of x equals x squared. So x, y, and the basic points for quadratic parent function is going to be -3, -2, -1, 0, 1, 2, and 3. F of -3 is 9. We just square the number. F of -2 is 4. F of -1 is 1. F of 0 is 0. 1 is 1. 2 is 4. And 3 is 9. We're just plugging it in and squaring the number because look, f of -3 equals -3 squared, which is 9. All right, so that's the parent function. So let's graph those points. -3, 9, 2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, -9. So you should get a parabola. All right, that's the parent function. So now let's graph, and we're going to do this mathematically. The horizontal translation, f of x equals x plus 5 quantity squared. So let's use some numbers x and y. Let's use -7, -6, -5, -4, and -3. When I plug in -7, so f of -7, what do I get? F of -7 is going to be -7 plus 5 quantity squared. What is -7 plus 5? That's -2. And we got to square that, and that is 4. Okay, what would f of -6 be? F of -6 equals -6 plus 5 quantity squared. -6 plus 5 is -1. And -1 squared is +1. So it's going to be 1. We're going to see that f of -5 is 0, f of -4 is 1, and f of -3 is 4. So let's plot these points. -7, 4, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. -6, 1, -5, 0, -4, 1, and -3, 4. So our new function looks something like this, and we can say that it translated 5 units left. There we have it. But that was kind of tedious. We had to do a lot of math there. So let's look at how we can use the rules of translation to go ahead and find our answer. This last one over here. Graph the horizontal translation of f of x equals x minus 3 quantity squared. Looking at the equation, what do you think the graph will move by? If you look at the equation, you would think that the graph is going to translate 3 units right. Remember, because it's negative, which means right. The -3 means to the right. Okay, so let's just look at our original parent function, take all the points and move them 3 spaces to the right. So down here we got 1, 2, 3 spaces right there. Over here we got 1, 2, 3 spaces right there. Same thing with this next point over here. I'm just going to do that with all our points that we had in the original parent function. So our new graph is going to look like, the points are going to be this. Then we can just take the points from the graph and use that for our table. We can see that our furthest left point is over here. It's 0, 0, 9. We got the next point right here is 1, 1, 2, 3, 4, 1, 4. Next point is going to be over here at 2, 1, 1, 2, 1. Next point is 3, 0. Then 1, 2, 3, 4, 1. And so on and so forth. So you can see with the rules of translation, it makes it a lot easier. And now for the final one, we need to know what to do if you have something like this, where it's multiple transformations in one. How do you think the function f of x equals x minus 3 quantity squared minus 4 will compare to the parent function of f of x equals x squared? Looks a little jumbled, but really it's just 2 translations in one problem. So we're moving the parent function twice. So what is one of the movements? One of the movements is told by right here, the minus 4 at the end. The minus 4 at the end lets us know that we're going to move down 4 units. And then the other that we see is going to be on the inside here, the minus 3. And that tells us that we're going to go right 3 units. So to find the graph of this function, all we have to do is plot the parent function, f of x equals x squared, and then shift all the points down 4 units and right 3 units, and that will be our new function. And that's how you do 2 transformations in one problem, and that's the end of these notes. See you in the next one. Peace!